Hi everyone, Grant for the Flame Learning channel. In the previous videos of this series, we focused on the various workflows of adding depth of field blurring using physical defocus. Now you can review those videos to go over the various scenarios, but the one thing in common in all the workflows is using Z-depth data. More specifically, normalized Z-depth data. This is a requirement to perform any depth of field blurring. I touched on this a few times in the previous videos. But because this is so important, I decided to make a standalone video on normalizing the Z-depth data, which can then be used in a variety of processes, including depth of field blurring. You can follow along with this video by downloading the media. The download link is available in the YouTube description, or type the link displayed on the screen. So in Batch, go ahead and import the media as a multi-channel source clip. Now toggling through the different channels, you have a beauty pass, a matte pass, and a Z-depth pass. Regardless whether you're working with embedded multi-channel media or separate render passes, the Z-depth channel is normally rendered in absolute values by 3D render engines. This dataset is huge and typically can run into the thousands of values. So don't be deceived by the solid white color. The information within this frame is giving you the absolute distance between the 3D camera and 3D objects. Now for compositing purposes, this data needs to be mapped between a range of 0 and 1 to make it easy to use. This process is what we call normalization. Now, physical defocus contains its own normalization tools that you can use in a matchbox node, the image node, and the Action 3D compositor. This was all covered in parts 1, 2, and 3 of the series. But if you just want to normalize a Z-depth channel for later use, you have another matchbox shader that just contains the same normalization tools. Switch to the matchbox node bin and locate the Depth Normalizer. Now connect your beauty pass into input 1, the Z-depth pass into input 2, and finally the matte, if you have one, into input 3. When you look at the result of the Depth Normalizer, the default settings already give a potential result. This is actually not correct because you need to set your nearest and furthest point in order to define the actual depth of the 3D scene. So in order to get the correct normalization, you need to know a bit more about the depth of the original 3D scene. If you know the values, you can dial them straight in. But if you need to work out the correct near and far values of your scene, I recommend the following steps. Switch to the original Z-depth input. So once again, you are looking at the original absolute values. To measure the data in the Z-depth channel, bring up the color sampler. Now as you move the box around, you can see that there are lots of values stored in the image. You need to find the highest value to determine your far plane. To make life slightly easier for you, you can switch to the beauty pass and place the box on the furthest visual point. The sampler will remain active, and when you switch back to the Z-depth input, you'll be told the value of the pixel that defines the far plane. In this case, it is 5000, which actually matches the camera settings in Maya. With that information, you can close the color sampler and switch back to the result of the Depth Normalizer. Now the default setting of the normalization is set to near far. This means that black represents the objects closest to the camera, and white represents the furthest objects from the camera. This is how depth data is represented in a lot of 3D rendering engines, including Arnold. You can choose other options if your depth data is different, and I especially want to point out the min-max option. This maps the highest and lowest pixel values between 0 and 1. This could be helpful if you just cannot figure out the correct near and far values. Once again, this is not physically accurate, but it is usable if you work with the data. Since you do have the right values, set the normalization to near far and set the far value to 5000. This matches the far clipping of the original 3D camera in Maya. So now you have the Z depth data correctly normalized between 0 and 1, and this can be used in other processes within Flame. So to make the point, add a physical defocus node to the batch flow graph. Connect the beauty pass to the first input. Next, connect the Z depth output from the Depth Normalizer to the second input. And finally, connect the matte to the third input of physical defocus. When you look at the result of physical defocus, you can see the depth of field blurring already taking place. Since the normalization was done in the Depth Normalizer as a separate operation, you do not need to use any normalization controls in physical defocus. This is the same for the image node and the action node in batch or batch effects. You can proceed to set a focal point with the depth position and refining the blur to your liking. Now, considering the bokeh, everything you have seen up to this point is procedurally generated. There are plenty options to choose from, but in the upcoming video, you'll learn how to import a sample bokeh and use that with physical defocus to match a physical lens. Don't forget to check out the other features, workflows and enhancements to Flame 2021. Comments, feedback and suggestions are always welcome and appreciated. Please subscribe to the Flame Learning channel for future videos, and thanks for watching.